because 367 question perfect square, a valid perfect square. So basically, we are given a positive integer num, while a function which returns true if num is a perfect square, else false. So do not use any built-in library functions such as square root. So for example, 16, we know it's like 4 times 4 is 16, so it's perfect square. So we will return true. If our input is 14, we'll return false because it's not a perfect, valid perfect square. So obviously you can brute force it, so you can just go over 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, and check whether the square of those numbers is equal to the num itself. If it is, then you can return true, otherwise you can return false. But that solution's time complexity is going to be O of n, and if you submit your solution, you will exceed the required time complexity, so we should find a more efficient solution than the brute force one. So a more efficient solution is easy to think we can use binary search, right? So instead of searching 1 to 16, we just search the middle number, which is probably 8. So 8 times 8 is 64, which is larger than the 16. So we can search the left part of the array. So the left part, 1 to 8, and we search the middle number, which is 5. 5 is larger, 5 times 5 is 25, which is larger than 16. So we search the middle point of 1 to 5, which is 3. 3 times 3 is 9, which is too small for 16. So we search the middle number of 3, 4, and 5, which is 4. And 4 times 4 is 16. And we can return true. So basically, we are using the binary search for our solution, and the time complexity is going to be O of log n. So for binary search, you just have to remember there is a template for binary search. Let me just code it up. So first of all, let's handle our corner case. If our num is equal to 1, we are already given a positive integer number, so we don't have to handle whatever is less than 0. So if num is 1, just return true because 1 is a perfect square number. And also meaning that our number is going to be 2 or a number larger than 2. So for binary search, you just have to know that you have to have a left and right. So our left is going to be 1. You can put it 2 to put 2 here because obviously the smallest number is 2, but yeah, it doesn't matter. So our right is going to be num because yeah, so we basically search the array because the square root of a number won't be larger than the number itself. So our right is num. So so this is the template for binary search. While left is less or equal than right, and we have our midpoint, which is left plus right, and divided by 2. I'm using the integer division here because I don't want to get a decimal point number. So the square is going to be mid times mid, and basically we just compare if our square is equal